All right, college algebra. Welcome to day one of Unit 8. To this unit, we're going to start studying exponential functions and logarithmic functions. So let's start with what types of functions you already know about, and then we'll begin studying this new one. You already know each of these functions and how to graph them. Number one, what type of shape would this graph create? Hopefully you're like, that's mx plus b. That would be a line. So I'm going to go ahead and say line right there. Number two, oh, that's easy. That's an x squared. That would be a parabola, a U shape, if you will, and it would face up because of the positive. The next one, that's a cubic. That's like the S shape, and it would go down up because it's positive. And this is a polynomial of 15th degree because 7 plus 8. I know it's an odd polynomial, so I know the end behavior would go down up because of the positive leading coefficient. At -4, there would be a 0 that the graph would pass through. And then at -2, there would be, or sorry, +2, there would be a 0 that the graph would bounce at. So I know the basic shape. After the next unit of study, you will know the basic exponential graph shape. So here we are. What about this function? F of x equals 2 raised to the x power. Right now, you probably don't know. What shape would that create? I know the previous ones, but I don't know this one. So let's answer some preliminary questions. And just so you know, this is a parent graph. This would be the parent function for an exponential equation. So let's study it and see what types of things happen with it. Answer the questions based off of the graph. Where is the horizontal asymptote located for the function? Think about the value for f of x or y, what y is approaching as x gets infinitely small. So obviously it would be helpful to do a table. And let's see what happens at like negative, we'll go right around the origin. Let's go like -5, -4, -2, -1, 0, and then we'll mimic those points just because, you know what, this is our first time working with this function. So let's see what comes out for y. As I plug in -5, 2 to the -5th, that would be 1 over 2 to the 5th, aka 1 over the 32nd power, or a really tiny fraction. So I'm going to have the point -5, 1, 2, 3, 4, 5, 1 over 32, or 1 over 2 to the 5th. As I plug in -4, that would be 1 over 2 to the 4th, also known as 1/16. So -4, 1/16, it's a teeny bit higher than that one, but not much. When I plug in -2, I would get 1 over 2 squared, aka 1/4. So I have -2, 1/4. And I know that there's points in between here as well. And if I think about what's happening at -6, -7, -8, -9, well, I keep getting smaller and smaller valued fractions. They keep getting closer and closer to the y value of really 0 because they're getting smaller and smaller and smaller and smaller in value. If I plugged in -1, continuing this table off, I'd have 1 over 2 to the 1st, or 1/2. So -1, 1/2. As I plug in 1, or as I plug in 0, 2 to the 0 power, any number to the 0 power is 1. So I have the point 0, 1. As I plug in 1, I would have 2 to the 1st, which gives me 2. Plugging in 2, I have 2 squared, which gives me 4. Now I can see, hey, those fractions were really tiny, but now I'm increasing. How? Exponentially. So I have 2 to the 4th gives me 16. 2 to the 5th gives me 32. So I have, and now I'm like, you know what? I can't even graph this. When I plug in 4, 1, 2, 3, 4, it's way off my graph. It's increased so fast. I should say it's been increased exponentially, aka our first exponential function. Okay, now that I have this, let's answer these questions. Where would be the horizontal asymptote for this function? In other words, think about what values the actual function, or you could say y equals. So what values are y approaching as x gets infinitely small? So as x gets smaller and smaller and smaller and smaller, remember, if it was like -10, then your value that comes out for y would be 1 over 2 to the 10th. Or if it was like negative 100, it'd be 1 over 2 to the 100. That's getting closer and closer to 0. So we actually have a horizontal asymptote for all exponential equations. And if you're looking at the parent function, it's at y equals 0. So as x approaches negative infinity, you can think if you think about y equals 2 to the x, y equals 2 to the negative infinity, oops, that's an 8. Negative infinity would simplify to y equals 1 over 2 to the infinity, which is approaching 0. So our horizontal asymptote is at y equals 0. Voila, first nugget to know for today. Number 2, can 2 to the x ever equal 0? Look at this function. Can the y value ever equal 0? Well, let's think about it. 2 raised to what power would equal 0? Obviously, if x is positive, you're just going to get a big number. If x is equal to 0, what would happen? That equals 1. Not going to happen. What if 2 is a negative number, like 2 to the negative third? Well, then it just becomes 1 over 2 to the third. It becomes a fraction. So is there any number that I can use to plug in for x that would equal 0? No, no, it's never going to reach 0. That's why it's an asymptote. It's going to get closer and closer and closer, but never actually touch. So no, because 2 to the negative infinity approaches 0, but it doesn't actually reach 0. Number 3, can 2 to the x ever equal a negative number? Basically, if I have the parent graph, am I going to have anything down here? Obviously, you can see there the answer is no, but let's think about why. Again, if I have 2 to the x, when x is positive, then y is bigger than 0. When x is equal to 0, y is equal to 1. If you think about equals y. And when x is less than 0, again, y approaches, or we could say approximately, but I'm just going to show y approaches 0. Y goes towards. Okay, so can 2 to the x ever equal a negative number? No, the most it could equal would be 0, 1, or positive infinity. And it can't equal 0. It gets really, really, really close to 0. So close to 0, 1, or positive infinity. So no. What ordered pair will every graph of this form? This is my parent function of an exponential. So what ordered pair will every graph of the form f of x equals a to the x, where a is a real number, pass through? What number will always work? Well, when x is equal to 0, let's think about that. What would happen? F of 0 would equal a to the 0. It's going to equal 1. So what's the point that will always pass through? 0, 1. Are you sure? Did it happen up here? Well, yes, it did. 0, 1. Okay, that's the key information. Let's build on that. Now, to sketch the graph of various exponential functions, you must recall the rules for transforming functions on a graph. So let's recall with some of the ones we've already worked with and then extend it to this new graph. Recall with quadratics. How does the function quantity x plus 5 squared differ from the parent graph, x squared? Hopefully you remember that if it's inside with the input or with the x, it's going to go left 5 units. Oh, I should have answered it here. Yeah, my bad. Left 5. Okay. So now, using this knowledge, what do you think is going to happen when we now put plus 5 in with the input, in with the x of the exponential equation? In fact, if you had an old calculator like me, when you entered this in, you would have to put it in parentheses, otherwise the calculator wouldn't know that plus 5 went with the x. So how do you think it's going to shift? The answer will be left 5. So here's the key piece to know. We just graphed the basic parent graph. In this case, the base is 2. So if you use the parent graph 2 to the x, we had a point of 0, 1. If you think about plugging in 1, you had 1, 2, because 2 to the first gives you 2. When you plugged in -1, you had -1/2. And then all these points approach 0 and go through that shape. So now if I take and I'm graphing this graph, I need to go left 5 units. 1, 2, 3, 4, 5. Take that, move it left 5 units. 1, 2, 3, 4, 5. And then take that other point, move it left 5 units. 1, 2, 3, 4, 5. And all these other points are going to move as well. They're still approaching 0 because all of those fractions just moved left 5 units. And I go ahead and keep going up. If I wanted to know the y-intercept, what happens when x is 0? 2 to the 5th power would give me 32, way up there. But right now I just want to sketch the shape. Now, let's talk about what would be the domain of this function. Remember, domain are the x values. And I'm going to look at my function that was graphed, and I moved, the x values move left to right. I'm looking what's the smallest value of x that exists for this function and what's the largest value of x. This function goes forever to the left and to the right. So the domain is going to be -infinity to infinity. When I look at the range, I'm looking at what are all the y values, or what are all the real number y values that are being produced on this graph. As I look at the y values, I like to look down and up. So as I'm looking down, there's no graph around here. So there's no negative y values. Where do they start? Ooh, it looks like at 0, this graph's starting, but it's not touching it. So how do I show with a symbol that it's very close to, but doesn't touch? A parentheses, 0 to infinity. What's the asymptote? It's still at y equals 0 because the graph just shifted left or right. It doesn't go up or down. So we would have y equals 0. You could check your work using the graphing calculator, but you've got homework. We'll maybe check a few of those later if you want to. It's always good to do. Moving on to the next function. How do you think the x minus 5 is going to move from the original graph? Hopefully you're looking at -5 is in with the input. It's in with the x. That's going to go dun, 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 right 5. So take your parent graph, which has values like, so I'll tell you, your parent, the one that you should learn from and move from is 2 to the x. So we have points like 0, 1, 1, 2, -1/2. And we go do, 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 do. There's my parent. But now I'm going to move right 5 units. 1, 2, 3, 4, 5. So the point 0, 1 now moves to 5, 1. The point 1, 2, I need to move that 5. 1, 2, 3, 4, 5 now goes to 6, 2. And then the last point, which was at -1/2, goes right 5. 1, 2, 3, 4, 5. And that now goes to 4/2. And everything else follows. And now I have that new graph. Didn't have to make a table, just use what I knew about transformations to graph that nicely. The domain, if I look at how far does this graph go from left to right, or what are all the possible real number x values that you can input to this graph to get a real number y value, that answer would be -infinity to infinity. When I look at the y values, how far does this graph move up and down? Start down, because we start with negative y values, nothing there, and it goes from 0 to infinity. What would be the location of the asymptote? Y equals 0. That was fun. Let's do the next page. Next page. Go back to something you already know. Connect it to something new. That's the best form of learning. So if I look at this graph, which we've graphed in the past, f of x equals x squared plus 5. How does this graph move from its parent graph? Up 5, of course. Up 5. Notice the 5 is not in with the input. It's not in with the x. It's outside of it. So it's going to move along the y values. It's going to go up 5. Okay, based on this knowledge, sketch the new graph. F of x equals 2 to the x minus 3. How do you think this graph is going to move based off of that review question? It goes down 3, of course. So let's see how we would use that. F of x is equal to 2 to the x, which looks like it would have points of 0, 1 included on all parent graphs. And then this specific graph would have 1, 2, negative 1/2. And I got and then I have to go down 3. This is new. Take 0, 1, go down 1, 2, 3. Now it's at 0, negative 2. Take 1, 2, go down 1, 2, 3. Now it's at 1, negative 1. Take negative 1/2, go down 1, 2, 3. And now it's at negative 1, negative 2.5. And all of these points are going down 1, 2, 3. They were approaching 0. Let me say that again. They were approaching 0, but now it's changed everything. I bring this down to, there's a new asymptote, y equals negative 3. Okay, so what is my domain? Well, the graph still goes forever left and right. So my domain is still every value of x will produce a real number value for y. But now, what is my range? Go up and down. Where does this graph start? It's close to negative 3, so close. Not equal to negative 3, super close. So how do I show that? Parentheses, negative 3, 2, and then it keeps going up along the y-axis to infinity. That's my range. The location of the asymptote. Ooh, I talked about this. We moved everything down 3. So no longer is the asymptote at y equals 0. It is now at the y equals negative 3. You could check your work on your graphing calculator. Tell me if I'm wrong. Move on to the next one. Based off of what you just did. How will this one move? Oh, my goodness. This will go up 3. So take your parent graph. Oh, I've been doing all the moving ones in blue. So my parent graph is f of x is equal to 2 to the x. Do you know it by now? It's going to have points like 0, 1, 1, 2, negative 1/2. And it's going to go do. But now I need to take it and move it up 3. Take the point 0, 1, and it goes up 1, 2, 3 to 0, 4. Take this point, go up 3, 1, 2, 3. Take this point, which was at negative 1/2, and go up 1, 2, 3. And all these other points, which were approaching 0, now get moved up 1, 2, 3. So what are they approaching now? It's no longer 0, my friend. No siree. What is it approaching? What is this new horizontal asymptote? I'm sure you know, y equals 3. So I can erase the parent graph if I want, because I just used it to help me sketch, so I didn't have to put a million points in a table to see what the shape would be. And my domain. This graph goes forever, left and right. So it would be negative infinity to infinity. What would be my range? How far does this graph go up and down? I want to say it starts at 3. It's really, really close to 3, but it will not equal 3. So I'm going to do parentheses 3, 2. Where does it stop? Where does it stop? It doesn't. It goes on forever. Infinity. Location of the asymptote. We talked about this. Y equals 3. Moving on up. We've done left reflections, right reflections, up reflections, down reflections. What's the last thing? Or we've done movements. Last thing is reflections, of course. So let's recall what we already know. With quadratics, the negative, notice this is not inside with the input. This is not with the x. This is actually going to be affecting the y values. But you have to know, where does it go? It reflects over the x-axis. It goes upside down. So in a case like this, this is also, it's actually affecting the y coordinates, but it's going to be reflected over the x-axis. So let's see what this looks like. If I think about, sorry for all of the voices, I just like to do voices. I have f of x is equal to 2 to the x is my parent. And I plot that. I have 0, 1, hopefully you know it by now, 1, 2, negative 1/2, a bunch of other points that I already used in a table earlier on to know that the shape would look like this. But now I want to look and graph my new one, which is going over the x-axis. So 0, 1 is going to be reflected to 0, negative 1. Notice it's the y coordinate that's affected. 1, 2 is going to go down to 1, -2. -1, 1/2 is going to go to -1, -1/2. And all these other points, are they still approaching 0? Yes, just below the x-axis. And they're going to be reflected all down here. Look at your domain. In other words, you can see how far does this graph move left and right. It goes forever to the left. It goes forever to the right. So it would be -infinity to infinity. My range, what are all the y values that are coming out for this function? Well, it goes forever down and then it goes up, but it kind of stops right here. This was my parent. That's not going to help me with my y's. So it starts down at -infinity and it gets really, really close to, but doesn't touch 0. So it would be -infinity to 0. What's the location of your asymptote? Well, still approaching that line. Y is equal to 0. One last reflection we must talk about. And then we'll do a little bit of practice. Recall how to reflect around the y-axis. The y-axis, in a case like one you've already seen, the negative has to go in with the input, in with the x. Like f of x equals -x to the 3rd power will reflect over the y-axis. It's the x coordinates that are actually affected. They're made negative, but visually it's reflected over the y-axis. How will that look in our new graph? Again, the negative will be in with the input. When it's in with the x, it's going to reflect over y-axis. So what's that going to look like? Start with your parent graph. Y equals 2 to the x. You need to have this memorized, really. 0, 1 is one of the points that will always be on there. It doesn't matter if the space is 2 or 3 or 4 or 1,000. It'll be 0, 1. But then the other 2 points around it will be different. Like since it's 2, I have 1, 2, and -1, 1/2. Here's my parent graph. But this new graph has the same base, but it has a negative with the x. So it's reflected over the y-axis. 1, 2 gets reflected to -1, 2. 0, 1 gets reflected to -0, 1. Oh, that's the same point. -1, 1/2 gets reflected to 1, 1/2. And notice all those x coordinates are what's being affected. And all those points which were approaching 0 to the left are now approaching 0 to the right. Here is my graph. I love it so much. And what would be the domain? Well, it still goes forever to the left and the right. Still has x values going from -infinity to infinity. The y values, where does it start along the y-axis? It looks like it starts at 0. Don't let it fool you. It's getting really, 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 really close to 0, but not actually touching. So we're going to do parentheses, 0 to infinity, because it goes forever up. And the location of your asymptote. Hopefully you know it's still at y equals 0 because it's still approaching those points. Don't believe me? Check a calculator, but you do need to know how to graph it by hand. And now to the practice. If you want to pause the video and then just fly through and see, hey, did I get these answers right? That's fine. I'll be walking through it. So let's go ahead and take a look. X minus 1. Hopefully you know that is going to go, it's in with the x, so it's going to go right 1. What's your parent graph? F of x equals 3 to the x is your parent graph. So what points are those going to have? 0, 1 is always a point. But now if I plug in 1 for x, I'll get 3 out. And if I plug in -1, I'll get 1/3. So this is my parent graph. And then how is it going to move? Right 1. So I'm going to take 0, 1, move it to the right 1, 1, 3, move it to 2, 3, take -1, 1/3, and move it to 0, 1/3, and all those other points are shifted as well. We just had to sketch the graph. Do not use your calculator, whereas the other ones you could have checked on your calculator. How about number 2? Number 2, we have +1 in with the x is going to move this graph to the left 1. -4 is going to move the graph down 4. So if I think about that parent graph of 0, 1, 1, 3, -1/3. Now I'm going to take this and I'm going to move every point left 1 down 4. So left 1 down 1, 2, 3, 4. Take this point, go left one, down 1, 2, 3, 4. Take this point, go left one, down 1, 2, 3, 4. And all of these points, since they're all shifted down 4, they're going to be approaching the new horizontal asymptote, y equals -4. And sometimes it's helpful to draw it to show like, hey, I might have been squiggly in my writing because I'm on a computer, but it's really not approaching that. On to the next one, number 3. Number 3, this one is the negative is not in with the x. So it's going to reflect, it's actually affecting the y coordinates. It's going to reflect over the x-axis upside down. So if I think about my parent graph, like 0, 1, 1, 3, -1, a third. It's got to reflect over the x-axis upside down. So it's going to go 0, 1 is going to go to 0, -1. 1, 3 is going to go to 1, -3. -1 a third is going to go to -1, negative a third. And all of these are going to go down like that. I might want to show the reader, hey, it might look really close, but it's not actually touching y equals 0. Wonderful. Moving on. Number 5. Number 5. How could I think about this one? Wait, I didn't do 4, did I? Zooming in, skipping. Yeah, number 4. Okay, this one's tricky. And hopefully if you were trying this on your own, you stopped at this point in the video, because this here, if I thought about a table for this, this is not in the form y equals a number a to the x, where a has to be greater than 0, which is important for the parent graph. Because if I thought about a table for this, look what happens if I plug in like -1, I would have -3 raised to the -1st, which would be 1 over -3. So I'd have a point like -1, negative a third. If I plug in 0, I would get -3 to the 0, which gives me 1. So now I have the point 0, 1. If I plug in like 2, I'm going to get -3 squared. -3 times -3 gives me 9. So I'm going to have 2, 9. If I plugged in like 3, now I'm going to have -3 cubed, which will give me -27. So now I'm jumping all the way down here, 3, -27. And notice I'm not getting a exponential shape. And the reason being is because a has to be bigger than 0 when you're looking at an exponential. So this one was meant to trick you. This does not, it's not an exponential graph. Yeah, okay, but then number 5. Number 5, you could actually write this one as, so it's the same as g of x equals, think about 1/3 as 3 to the -1st raised to the x. And then back to the prerequisite unit, when you raise an exponent to an exponent, you do what? Multiply, of course. Oh my goodness. So I have 3 raised to the -x power is actually what this is the same as. And so what is that there? That's a reflection. Reflect, it's in with the x, so it's going to reflect over the y-axis. So if you use your parent trap, don't let it trap you, it's a parent shape. 0, 1, 1, 3, and -1 a third. We need to reflect that. So we're going to go to negative, well, reflect that guy. Reflect this guy in on itself, reflect that guy, and everything gets reflected like this. And we have the horizontal asymptote. All these points are approaching, but never reaching y equals 0. That's it. You guys have homework on campus. Hope you enjoyed the show. No, the notes. And great rest of your day. Let me go ahead and stop this. Stop.